Hello everyone, welcome back guys. Hope you all are doing well. This is Muhammad Badrudduja and today we are going to solve lab number 5 from race condition vulnerability module from Portswigger. And before going further, as always, maybe it's a bit annoying, but this is important. This video and its content are only for educational and awareness purpose, and I do not support any unethical or illegal act. That's been said, if you did not subscribe the channel up to now, please subscribe the channel and let's go. So the lab is saying exploiting time sensitive vulnerabilities. So there is some time sensitive issues. This is particularly not a race condition vulnerability, and we will see that in a minute. So this lab contains a password reset mechanism. Although it does not contain a race condition, as I mentioned, you can exploit the mechanism's broken cryptography by sending carefully timed request. Okay. So to solve the lab, what we need to do here, that we need to identify the vulnerability in the way the website generates password reset tokens. Okay. And obtain a valid password token for the user Carlos, log in as Carlos and access the admin panel and delete the user Carlos account to solve the lab. And we have another genuine credential for winner user, right? So we will act as a winner user and we need to impersonate us as Carlos, or in somehow we need to generate a token for the Carlos, and then by accessing that token we reset the password for the Carlos account and we will log in as Carlos. Now Carlos user has administrative privileges, so we will be able to access the admin panel and we will delete the Carlos account. Okay. Let's go to the lab now, and I'm directly going to my account. Here we go, and I'm now going to turn on the burp proxy on my browser. There is forget password. So there is one more interesting part here, that we have a email client. This is very much similar situation when you are trying to forget password, when you are trying to resetting your password and the website send you a link on your email to reset the password. So because this is a lab environment and they will not give you any authorization to go out of band interaction with the email services or something like this, so they inbuilt this email client for you within this lab. So you can consider this email client as your email, right? Okay, so now I'm going first to forget password. Okay, and here they are asking us about our email or username. So our username is WIENER winner. Submit that, and as you can see, please check your email for a reset password link. This is very similar to very real scenarios, right? Now I'm going to check my email by accessing the email client, and there you go. So now this is the link by which you can reset your password. Okay, so if you see this link closely, just wait a moment, copy that back here, and I'm going to paste that here. So this link actually contains two parameters. The first one is username, which is winner, our username, and the second one is token, and this is some random token. We don't know what it is, but we will try to figure it out what this token is all about. So now what I'm going to do here is going back to our proxy, and this is the post forget password request. I'm going to send this request to the repeater, go to the repeater, and let's try to send another request. So we sent two requests, right, to reset the password for the winner. Now back to the email client and just refresh your email client, and we got two more. This is the first one, and now because we sent two times, so we get two links, and in all of these links you can see the token value is different, but one thing is very similar in all of these token value, which is the length of the token. That means the number of characters in the tokens. So to confirm this, I'm going to copy this token value, open a terminal here, and I'm going to say echo space -n and paste the token pipe wc space -c to count the number of characters. So the number of characters are 40, and before we already had one token from the first request. I'm going to copy this one also, and let's try to make the same for this to count the number of characters in the token. Okay, hit enter. So you can see the length of this token value is same, means all of the tokens contain 40 characters, and this is randomly generated token. But one thing to be very convincing here, what, because of this result, because every token have the fixed length, and if you go to the cryptography, you can see the mechanism broken cryptography by sending carefully timed request. So in cryptography there is hashing algorithms, and this is the main quality of the hashing algorithm, that it takes input as a plain text of any length, but it hashed or generate the message digest of a fixed length. So as you can see here, the hashed value is a fixed length value. But what this hash value is all about, from where it is getting this hash value, we need to see that. One thing again I want to test, suppose if I send the same request to the repeater again, now we have two requests. Okay, and if I create one new tab here, let's say reset password, and I'm going to add both of the requests here and add in the group, and let's send both of these requests in parallel. Okay, so if we send both of the requests, we try to send it concurrently. Okay, because if we want to send it in a sequence, you can choose one of these. Okay, but we try to send it concurrently, parallel one. So once we send, you can see here in the right hand bottom corner, you can see three parameters here. The first one is the response size in bytes, the second one is the time, response time, and the third one is 1/2, that is the number of requests / total number of requests. So total number of requests is 2/1 means this is the first one from them. So the first response time is 752, and if we choose the second tab, you can see the response time is 885 milliseconds. So there is a gap or much time difference in the response. Let's try to send again, and once we send again, and the first request took 553 milliseconds and the second request took 855 milliseconds. So the first thing is these requests are not going concurrently because of this time difference. Okay, the second thing, if you go to the client and let's refresh this, and one thing to be noted here, that all of these requests we are sending for resetting the password of winner user. That means once we send this group in a parallel, we are going to have two reset link every time. So that means these two is the pair for the last what we send in the parallel, and you can see here that both of the link contains different token. Okay, so that means it is always generating the random token for each request for the reset password. What we can do here, we can test one more thing, because as you can see here, both of the session cookies, the first thing to be noted is the backend is using PHP, and so that we have here PHP session ID. The second thing here is both of these requests containing the same session ID and the same CSRF token. So what if we change these two values? So let's see, I'm going back to burp proxy, and let's go to the send this get forget password request to the repeater, and let's try to send this. So once we send this request with this PHP session ID, let's see what happened. Okay, so you can see if we send with the same session ID, because this session ID, this session ID, this session ID, all these session IDs are same, and hence we have the same CSRF token. So FRV5, FRV5, and here also FRV5. So what if I delete this session cookie? Because in that way it is going to generate new session ID for me with the new CSRF token. So send this, and as you can see, it generates new session ID for the new session, and it also generates new CSRF token, right? So I'm going to copy this value and go to the second tab, and I'm going to paste the new CSRF token value and also the new session ID. This one, copy, go to the second tab and paste it here. Now that we have both sessions are different, session ID and the CSRF token, session ID and CSRF token. In the both request, these two parameters are totally different from each other. That is pointing to a different sessions from each other. And one thing is similar, which is username. So we are trying to reset the password for the winner user, but from different sessions with different CSRF token. And now send this request again in parallel within a single packet attack. So once we send it, let's see what is the difference, because it is very important to see the response closely and the behavior of the application closely. Okay, now we send. As you can see, this response time is 3060 and the second one is 3061. This is very close, because before, if you remember, before, you can see the time difference is too much. You can see 752 and this one is 885, but this time the time difference is very close. So 360 milliseconds for the first response and 361 millisecond for the second response. Very close. And if we go to the client, email client again, okay, let's see how we can identify. I'm going to copy this. This is the last generated reset link, right? So I'm going to copy this token so that I can identify what was the last reset link. Back here, refresh one more time to just be sure. Yeah, this one was the last. I'm going to send the request in parallel one more time with different session ID and CSRF tokens. Okay, and back here to the email client, the first thing, just check the response time, 1171 milliseconds and 1173 milliseconds, very close. Okay, back to the email client, refresh the email client one more time, and as you can see, 0C19 and DD96C. So 0C19 DD96C, yeah, this was the last one, and these two are the new one, because we sent the request 2 times, okay, but with different session. And you can see one thing very interesting here, that the token this time the token is same. Once you send the request in parallel but with different session, at that instant the request is processed at a very same time. And once these two requests are processed by the server at the same time, that means the timestamp value is approximately same, because you can see here this response time is in milliseconds, but if you take the time in seconds, it is going to have no difference in that. Okay, and that's why we are getting the token value is same. So that means if we change here the username from Wiener to Carlos in the second request, so maybe for the Carlos it also generate the reset password link, but that password link is going to be equal to the Wiener user password link, right? Token value, the token value of the Carlos reset password link is going to be equal to the Wiener user token of the reset link. So here I'm going to copy this to just identify that this is the last token of the reset link, and I'm going to change the username here in the second request and send the request in parallel one more time. Go back to the email client, refresh the email client, and as you can see, this time we just get one response. This is the last token, right? And we just get one email with this token. Why we get one email? Because the second request is for Carlos. So the server is going to generate the reset password link, but that link is going to be forwarded to the Carlos email, not our email. That's why we get here just one reset link. What we saw in the previous result, that it is going to generate the same token for both of the requests. So it is going to generate the same token for Carlos also, but the email is sent to the Carlos email account. But one thing is very interesting here. If we copy this, come back here, paste it here, so you can see everything is going to be same. If it's generated the token same for the Carlos, then we can just change here the username as Carlos, and we can copy this back to the browser and open new tab, paste that, hit enter. If we get the response here for the changing password, that means it is going to work and it's for Carlos. If we just change one character here, we change the A with V and try to process, you can say invalid token, but username is Carlos and this is the token and we are getting response, that means this is for Carlos. So I'm going to change the password for Carlos 123456 123456 or whatever you need. Just a lab. Okay, go to my account, and this time instead of Wiener I'm going to log in with Carlos, and the password is 123456, and boom, we logged in as Carlos. And as you can see, we have the admin panel. Access the admin panel and delete the Carlos account to solve the lab, and we solved the lab. That's it for this video. It is a very good lab. So that's it for this video. I'm going to see you in the next video. Bye.